the talk we just did on fraud detection with Neo4j was designed really to show, first of all, what the challenges are for people who are in the fraud game, particularly the people who are the gamekeepers, the people who are trying to catch fraudsters. So it started off by talking about the evolution of electronic fraud and how banks have caught up over the last 30 years to many of the different ways in which people can defraud, but it's a Darwinian game, it's an evolutionary game, and the fraudsters need to keep one step ahead. And then we talked a little bit about how graph databases can be used to help you combat that, to move one step ahead of the fraudsters before they catch up. Well, the advantages of a graph database, I guess, are twofold. First of all, modeling. It's very easy to model the real world in Neo4j, and you don't have to make compromises as you fall suit into a rigid row, table, column structure. And the second advantage is performance. And that gives us access to some very challenging use cases that are difficult to achieve with other tools, such as social network analysis, such as physical IT network analysis, such as, for example, metadata management and master data management applications, identity access for making sure people are authorized to use IT resources, which can get a very, very complicated problem. Neo4j is great for that sort of thing. I guess at the moment the hotspots are in telco, network analysis. In retail, we've got a lot of traction with recommendations. Recommendations is an incredibly high-value problem because when a customer is on your website, you've got a chance to sell something to them, so you've got to put something appropriate in front of their eyeballs. Another one which has actually come up quite a lot in talking to the people at GoDataFest today has been life sciences. If you look at the structure of a molecule, you can see that is kind of a very connected structure, and Neo4j is very good for modelling that. But it's not just at a sort of molecular level, at looking at human populations, at conditions, at practitioners, all sorts of things. The relationships are very important, and a graph database is a great tool for expressing those. The thing that people are going to find most interesting is our Open Cipher initiative, which is allowing us to use our query language, which is called Cipher, a graph pattern matching language, outside our product. So there are other vendors, including SAP, who are using Neo4j to query their graph-like database, but also some of the data analytic tools, such as Spark, are now using Cipher as a query language. That's just one. A second one I think people are going to find very interesting is the increasing power of the graph algorithm library. So traditionally Neo4j has been thought of as a transactional product, an OLTP type of product, but there are more and more people who are using it for what we categorize as OLAP use cases, where what you're interested in is data patterns, and we're building facilities, tools to help you analyze data patterns in the whole graph rather than just transaction by transaction.